guys, here we are in video 1 of lesson 7, and lesson 7 is the end of part A for module 5. So good job working on properties of 2D shapes and hierarchies, right? How they relate to each other. And before you watch this video, please make sure that you already watched the YouTube video from Math Antics about properties of triangles, okay? Because you need to really understand your triangles before you can understand this lesson. And triangles is a 4th grade bent standard, so you have to know that first. All right, so here we are. We have a triangle in front of us. How can we classify this figure? How can we classify this figure? Think about it. Think about all the possible names that you know for this triangle. It's a polygon, right? A many-sided shape, closed sided shape. It's a triangle, of course. It's a right triangle because it has a right angle here. It is an isosceles triangle because it has two sides that are the same length. Two sides that are the same length. All right? So we're looking at triangles by their shapes. Now let me show you this. Ooh, this is cool. All right. This is, they call it a Venn diagram. We usually think of the Venn diagram as those two interlocking circles, right? Just two circles, and then where they overlap, right? We've done those before. But this, the book is calling this a Venn diagram too, and it's more than two circles, so kind of interesting. Just look at it for a minute and think about what you see, what you wonder there. Okay, maybe you're like me and you noticed, and you noticed that this is a right triangle and this is a right triangle, but this one is here inside of isosceles and this one is inside of right, but they're both also inside of right. Did you notice that? There's a lot of different categories. We have acute, right? They have acute angles. All of these are inside of acute. Then this one is just equilateral, all the same sides. Then these are all inside of isosceles. Look at that. Like isosceles has a little bit of everything, right? Because isosceles is two sides that are equal. You see that? Two equal sides. Then obtuse, this one is obtuse and this one is obtuse, but this one has two equal sides, right? Oh, that's the same thing with the right. Yeah, it's inside of isosceles. Interesting. And I don't see scaling here at all, right? Scaling is when you have no sides are the same, but some of these are scaling, right? Because if there's no sides that are the same, because it would be an isosceles, right? Because isosceles is two sides. So here's another scaling and here's another scaling, but they didn't include that on this Venn diagram. I see that everything is in different colors, that right angles are marked. Interesting. Looks like this is meaning that these two angles are the same, right? Here we have three angles that are the same. Okay, so there's a lot to look at on this Venn diagram. Let's look at our right triangles here, these two. We see that E is isosceles and right, and B is just right, just right, or it could be scaling and right. Yeah, let's look at F. F is isosceles and obtuse, right? Two sides that are equal length and two angles that are equal length and one obtuse angle, right? Here we have one obtuse angle. See, the angle is more than 90 degrees, right? More than 90 degrees. And no sides that are the same in letter C. Then let's look at G. Yeah, G, all equal sides, Also acute, notice 3 acute angles there. And also, do you see how it is inside of isosceles? Because even though it has 3 sides that are the same, it also has 2 sides that are the same. That's kind of interesting about geometry, right? We have 2 sides that are the same, and here we have 3 sides that are the same. So it has to have at least 2, right? If it has at least 2, it can have more than 2. That's kind of cool. Okay. So G is acute, equilateral, and isosceles. Acute has to have at least has to have 2 acute angles, right? You can see here. Oh, I'm sorry. It always will have 3 acute angles, right? Just because when you join them up, it's all going to match. And the angles are all going to add up to 180 degrees, right? That would be all triangles. All their angles add up to 180 degrees. Okay. Anything else? Would it make sense to put a quadrilateral in this diagram? No, because these are triangles, right? So if we had a quadrilateral, it would have to go out here, right? Maybe in a separate section. All right, so today we're going to classify and organize quadrilaterals in a Venn diagram. We were just practicing here on triangles, something maybe familiar. Hopefully you worked on those last year. Okay, so that's everything for this video. Let's watch a little bit more of how to make your own autograph. There we go. How to make your own autograph.
Much of a curve. So I'm thinking I'm just going to practice the H's now. So that's going to go up. It's going to right. We're going to go up, down, up, down, up, down, up, down, and it's almost a little bump at the bottom. Up, down, up, down, up, down. So I'm wanting to move this way faster than I'm going up. So I want to come up, down, up, down, up, down. I quite like that kind of very fast. It's almost just a little bump. So that we then come to Raj-ish like that. So it's not quite, it's a bit too fast. And we practice the R and the J with the dot. E-S-H. That's too fast. R, J, E-S-H. So there's an H that I kind of want to do here. I want to do this kind of very smooth thing there, like that. That's too much of a bump. So it's liminal is a word that comes to mind. We want so here I'm doing up and down, which I don't want to do. I want to do up, down. It's a bump rather than an up and down. So it's something like that.
As I'm in the midst of applying for residency right now, wish me luck.
Okay, let's watch more of that later. Thanks, you guys.